Hello, algebra, final lesson of the week. Nothing real new here, but we've been moving kind of fast, so I want to go over what we've done. I've had a lot of questions on how do I find axis of symmetry or how do I find the vertex? Aren't they the same thing? All right, they're not the same thing. So this is my little chart here to try and explain what's the difference and how you find axis of symmetry versus vertex. So on the left here, axis of symmetry. Axis of symmetry is a line. The line. Imagine if your parabola was on a piece of paper. It'd be the line that you would fold the paper on to get the two sides of the parabola to match up. Whereas a vertex is a point. So that's the main difference. Is that the axis is a line and the vertex is a point. So the point is at the very tip of the parabola. So it's also right in the middle of the parabola. The axis of symmetry is always going to go right through the vertex. So they're going to have the same x coordinate, basically. Well, that's maybe a bad way to describe it because a line doesn't have just one coordinate. All right. Let me. I'm going to keep going instead of deleting this and starting over. All right. Like I said, the axis of symmetry is a line. So when it says find the equation for the line of the axis of symmetry, you guys are used to thinking of y equals mx plus b as the equation of a line, and that's true, it is, but there's a special type of a line which is called a vertical line. That's a line that goes perfectly straight up and down. If you have a line that goes perfectly straight up and down, it's not going to be y equals something. It's going to be x equals something. And I know that's weird, but that's just how it is. It means, like, say this dotted line right here goes through the point 2. Say it was over 2 spaces. That means you pick any point on this line. Say I pick a point way down here. That's going to be the point 2, -5. Or I pick a point up here. That's the point 2, 4. Any point on this line is going to be 2, comma, something. So that's why it's x equals 2. It's everything on that line of x equals 2 is the equation of that line. So when you use the equation that I gave you in the past video, the negative of b over 2a, and you get a value for x, that is the equation of the axis of symmetry. You're done. X equals that number, that's your equation, that's the axis of symmetry. Now, if you have to find the vertex, now you got to find an x and a y, because now it's an ordered pair. It's an x coordinate and a y coordinate. You got to fill in that parenthesis right there with an ordered pair. So to get the x part, you do the same exact thing. You use the same formula, the negative of b over 2a, because that's going to be your x coordinate. And then to find the y coordinate, now this is a very specific point on the axis of symmetry. It's the point where the axis of symmetry and the parabola intersect. It's the very bottom of the parabola. So there is one specific y coordinate for this. And to get it, you substitute in the value of x. Whatever you got for x here, you substitute in that value of x into the original equation, and you solve for y. And that's your y coordinate for the vertex. So it's one more step to find the vertex than it is to find the axis of symmetry. You start off the same way in both, but if you want to find the vertex, you got to take your answer for x, substitute it into the original equation, and solve for y, and that'll give you your y coordinate. So I have another slate here with an example of that, and there's a lot going on here. It looks a little crazy, so before you start staring at it, let me tell you that on this slate, it's just one problem. And it's very similar. Actually, it's the exact problem of one of the 6 problems that you have to do for the homework tonight. So if you do the homework on Thursday, you're going to recognize one of these problems. Now, the directions in the homework say for these 6 problems to just factor it, the same thing that we did Wednesday night. But I don't want you to do that. I want you to do more than that. I want you to take what we've learned so far and show me a little graph of this parabola using 4 points. I want 2 x-intercepts, 1 y-intercept, and the vertex, the bottom of the parabola. So that's what this example is here. I'm finding all those points for you. So let's start over on the right-hand side. This right-hand side of the slate here, this is all finding the vertex. So to find the vertex, it's the negative of b over 2a, comma y. It's a point. Remember, it's an xy coordinate. So the x-coordinate is going to be the negative of 3 over 2a because I'm using this equation right here. X squared plus 3x equals 54. So a is 1, b is 3, and c is actually negative 54, not positive 54, right? Because the whole thing has to equal 0. So you got to subtract 54 to the other side. C doesn't really matter for the vertex. You don't use it. But that is the y-intercept. So your fourth point here, the y-intercept is actually negative 54, not positive 54, because you got to subtract it to the other side. You got to get the whole thing equal to 0 before you say what a, b, and c are. All right, so back to the vertex. The negative 3 divided by 2 times 1 is just negative 3.5. So this is where the problem gets a little bit ugly. You got to substitute in negative 3.5, or negative 3 over 2, which is actually negative 1.5, into this equation. So that's what I do on the next line here. Instead of x squared, it's negative 3 over 2 squared plus 3 times 3 over negative 2 minus 54. So when you square a negative, you get a positive. You square the numerator and you square the denominator. That's how you square a fraction. So 3 squared is 9, 2 squared is 4. So it's 9 over 4 minus 9 over 2. When you multiply a whole number times a fraction, it's the whole number times the numerator. Because remember, this whole number is actually over 1. So the denominator doesn't change. You're just multiplying the numerator. All right, now I made a common denominator of my 9 over 2, made it 18 over 4. And when you subtract 9 minus 18, you get a negative 9. So this is negative 9/4 minus 54. And instead of turning 54 into something over 4, I turn 9 over 4 into a whole number with a fraction. So 4 goes into 9 2.25 times. So negative 9 over 4, I made negative 2 and 1/4. And when you subtract a negative from a negative, you get a bigger negative. So this is negative $2.25 minus $54. Now you're at negative $56.25. Negative 56.25. So that's the y-coordinate. That's the x-coordinate of your vertex. So your vertex, I will show you now, is the ordered pair negative 3/2, comma negative 56 and 1/4. So I didn't want to write that in from the start and show you the answer and make this slate even more jumbled and confusing, but there it is. There's your vertex. Negative 3 over 2, negative 56 and 1/4. All right, so that's 1 point. We still need 3 more points. Really, we only need 2 more because we know that the y-intercept is negative 54. It's always the constant. It's always c. It's always the number that's by itself in the equation, as long as it's on the same side of the equation as everything else. It can't be over here by itself. It's got to be with all its buddies over here. All right, so all we have left to do now is find the 2 x-intercepts, which you can factor, you can use the quadratic formula, or you can complete the square. And I gave you 6 problems that all factor. Factor is the quickest way to do it. So unless you think it's easier to use the negative b plus or minus the square root of b squared minus 4ac over 2a, or you think it's easier to complete the square, go ahead and do that. But if you just want to factor, that's the quickest, easiest way to do it. So if you're having trouble factoring, I wrote these numbers down on the side because to factor, you got to find 2 numbers that multiply to give c, which is negative 54, and add to give b, which is positive 3. And it's always easier, if you're struggling with this, it's easier to figure out what are my options for numbers that multiply to give c. Figure that out first. So I wrote down your options here. You could do 1 times 54, 2 times 27, 3 times 18, or 6 times 9. Those are the whole numbers, the integers that multiply to give 54. And which one of these 4 choices could you combine, either adding or subtracting together to make 3? Well, it's the last one. This is going to make 15 or 21. That'll make 25 or 29. That'll make 53 or 55. So this is the only one that'll work. So it's got to be 9 and 6. How do we know which one's positive and which one's negative? Or are they both negative? Or are they both positive? Well, first of all, c is negative. So one of them's got to be positive and one of them's got to be negative. If you multiply 2 numbers together and they're the same, they're either both negative or both positive, your answer is positive. So when we multiply these 2 numbers together, we want our answer to be negative. So one's got to be positive, one has to be negative, and whatever b is, that's what your bigger number is. So b is a positive, so our bigger number has to be positive. All right, if we would have made 9 negative, then we would have ended up with a negative 3 here. So 9 is positive, 6 is negative, that's factoring, And I think that's all you had to do on Wednesday night's homework was factor, and you were done. But now I want you to do one more step and find the x-intercept. So what do you substitute into that parenthesis to make it equal to 0? You substitute in a -9. And what do you substitute into this parenthesis to make it equal to 0? A +6. So those are your two x-intercepts. So now we have our 4 points. -9 is 1 point. Well, some of you might say, well, that's not a point. That's just a number. A point is an ordered pair. And you're right. But on an x-intercept, the y-coordinate is always 0. So it's just assumed when you're talking about x-intercepts that that's the x-coordinate, y is always 0. So it's -9, 0. So that's what I graphed over here. Now this graph isn't to scale, and you don't have to draw your graphs to scale because these are going to be huge numbers. I just wanted you to draw a parabola, get it about in the correct spot, and then label your 4 points. So that x-intercept down over here on the left, that's my -9. This x-intercept over here on the right is 6. My vertex is way down here. That's over -1.5, which I used instead of -3/2. And it's all the way down to -56.25 right here. And then my y-intercept is at -54 right there. So those are my 4 points that I labeled. 1, 2, 3, 4 points. This is how you find the 4 points. Nothing new, but kind of combining everything together here and see if you could put it all together and draw some graphs. So we'll work on this more next week, but I want to kind of see where you guys are with this, how many of you are starting to get it. And if you're one of the ones that aren't, don't worry. We're still going to be working on it next week. So good luck with that.